So we are going to review for Unit 6B test. And it's really important that we know this. We know this, guys. We know this. So just stay with it. So when we approach a word problem, one of the first things we do is we read through the whole thing. Lydia is making cookies for a bake sale. She wants to raise $50 or more. She is selling each cookie for 50 cents, and she has to pay $10 for the booth. Select the inequality. So the first thing you want to do is you want to realize, as math teachers, we have seen you do each one of these things wrong on a problem like this. So you never want to start there. Where you want to start is you want to start marking up the problem. So it's $50 or more. And she's selling each cookie for 50 cents, but she has to pay $10 for the booth. So what I like to do is start with this $50 or more. And you look at it and you think, okay, $50, here's $50. Can she have more or does she have to have less? Well, she can have more. That'd be fine. So we always want to put the total here, which makes the inequality much easier. And we know what we're working with has to be greater than or equal to because it says $50 or more, so it can be either one. Then we have to look at what are we making money on, because $10 is what we're going to lose money on. That's what we have to pay out. So 50 cents per cookie for each cookie. So we're going to have 50 cents times X. Oh wait, they said C. Not a problem. We can be either one, but we'll use C. Okay, and then we have to pay $10 for the booth, so we're going to subtract 10. Okay, so one of the ways we can do is look at all the greater than signs. So this one won't work. This one won't work because we said greater than or equal to. This one won't work. Okay, so now we have a greater than sign. Oh, there it is. There's our answer. But you could see it could have been lots of other things. This one was a real tricky one. You had to be very sure on what you wanted to do there. Okay, now it says calculate the solution for this problem. So we want to get rid of the number that doesn't have the variable. So that means we're going to add 10 to both sides. And if you like it better, draw that line right there. So we're going to add 10. So we get 50 cents is greater than or equal to 60. We're going to divide by 0.50, or just 0.5. And we get C is greater than or equal to 120. Okay? Now, what does that mean? We'll come down to number 3. Lydia will have to sell at least how much? 120 cookies to reach her goal. Or we might have written it as 120 cookies or more. That would have been the same thing. Looking at number 4, we're going to solve an inequality. And remember, with inequalities, it's just like equations, except for when we multiply or divide by a negative. So I want to get rid of the 8. I have an 8, so I'm going to subtract an 8 from both sides. So I get negative 10C is less than 90. Now we're going to divide by a negative 10. Oh, what am I going to divide by? A negative. Divide by a negative. When you divide by a negative, remember that your inequality sign is going to go the opposite direction, and you're going to get C is greater than negative 9. Okay, looking at number 5, we're going to do that same thing. And if you haven't already done this on your own, pause it and try it all on your own so that you'll be ready for that test tomorrow. So the first thing we want to get rid of is this negative 5. If I have a negative 5, I'm going to add 5 to both sides because I want it to go to 0. So I'm going to have negative 11y is less than or equal to 55. I'm going to divide by a negative. Did you hear divide by a negative? That's right. Divide by a negative means I'm going to flip my inequality sign to go the opposite direction. So I get a negative 5. Okay, good. Again, if you ever have any questions on these, just pause it and go back. Number 6, again, we're going to read it first and we're going to mark it up. The hiking club is on a hike down a mountain. For safety reasons, the lowest elevation they are allowed to reach is 75 below sea level. They begin at an elevation of 25 feet and descend at a rate of 2.5 feet per minute. What is the maximum number of minutes the hiking club will descend? Okay, let's start marking it up. So we come to a number right here, 75 below. And they say that that is the elevation they are allowed to go to. That's the lowest one. But first off, let's pay attention to 75 below. That's a negative 75 because we're below. So that's the lowest we can go is negative 75. Okay? They begin at an elevation of 25. And they're going to descend at a rate of 25 feet per minute. Okay, a lot of marking there. So let's start with define your variable. Now, let me tell you the clue on define your variable. Look at the question. What is the maximum number of minutes? Right here, number of minutes. Just put that down here. Number, I'm going to abbreviate, and O dot of minutes. So always look to see what your question is. Whatever your question is, that's pretty much what your variable is. So number of minutes. Now write an inequality to represent this problem. Well, we can't go below negative 75. So once again, here's my negative 75. Can I go above it? Can I go below it? Which one? Well, they said I can't go below it, so I have to go above. So what we're doing has to be greater than or equal to negative 75. Okay? So what do I have? Where do I start? I start at 25 feet. And then I descend. What does descend mean in math? That's right, you're going to subtract. And whenever it says per, that means you're going to multiply. So 2.5 per minute. That's my inequality. Okay, now let's solve that. And again, if you haven't practiced this on your own, please do some on your own so that you'll get used to doing it. So here we go. We're going to move the 25. If I want to move the 25, I have a positive, so I'm going to have to add a negative or subtract 25. So I get negative 2.5x greater than or equal to negative 100. I have to get rid of the negative 2.5, so how is that connected? We're going to divide, right. So divide by negative 2.5. Ooh, we're dividing by a negative. When we divide by a negative, we have to remember that our inequality sign goes the opposite direction. So we get x is less than or equal to, is that 40? Yeah. So x is less than or equal to 40. Interpret your solution. We're going to write a complete sentence. Now, don't be too freaked out about that. All we're going to do is we take our question, what is the maximum number of minutes the hiking club will descend? And we just state it back to them. The hiking club will descend, and then we take our information. So here we go. The hiking club will descend. So see, we just take the question and we put it back at them. The hiking club will descend for 40 minutes or less. Because we have x is less than or equal to 40. Good, and let's put a punctuation on there too. Now graph your solution. So x is less than or equal to 40, so pick a 40. Okay, and this has to be 39. And this has to be 41. Okay, is this going to be an open or a closed circle? I'm giving you a hint. That's right, it's a closed circle at 40. And it's going to go off to the left. There we go. Okay, let's hit number 7. Now, I've just showed you number 6. If you want to, again, pause yours. If you haven't done number 7 yet, pause yours, try it on, then come back in. So we've read the problem, and now we're going to go through and mark it up. The temperature started at 50. Dropped at a steady rate of 6 per hour. Okay, how many hours until it's colder than 20 degrees? Okay, well, they're asking about how many hours, so let's define the variable. Number of hours. Then they're comparing it. How many hours until it will be colder than 20? So here we go. Here's 20. Do we want it to be above 20 or below 20? We want it to be below, so less than 20. Now here's one we haven't seen before. Colder than 20, not equal to, just colder than 20. Now what makes that up? So what we're talking about has to be colder than 20. Well, we start at 50, and then we drop. So mathematically what's happening? That's right. 6 degrees per, so that's what we're going to multiply, and number of hours is what we're going to find. So 6x. Okay? Now, if you're not sure what I just said, go back through what I just did. Okay, now we're going to solve this. Hopefully you've done this on your own. You have a 50, so subtract 50. It's all going to come out to be this many negatives. This is just, we're giving you lots of practice. Or equal to negative 30. We have a negative 6x connected to the multiplication, so we're going to divide by a negative 6. When I divide by a negative 6, divide by a negative. my inequality sign goes the opposite direction, so I get x is greater than 5. Let's interpret our solution. Again, pause yours if you haven't already and see if you can write it. So here we go. What was our question? How many hours will it be until the temperature is 40 degrees? So it will take 5 hours more than 5 hours will take more than 5 hours oops, we need the 5 there. Now, that is a complete sentence and you could stop there, but you could also say it will take more than 5 hours to be below 20 degrees. Both would be right. This one just answers it better. Okay, now we're going to take this inequality and we're going to graph it. X is greater than 5. Set an open or a closed circle at 5. Hopefully you set an open. And then, oh, this would be a 6. This would be a 4. And what direction is it going to go? That's right, if the variable is on the left-hand side, my inequality sign goes to the same direction. Okay, but it's only when the variable's on the left-hand side. Now, the other way I could have done it is picked the number. I could have picked 4 and plugged it in there. 4 is greater than 5. Is that true? No way, that's false. So that's the other reason we know that we're going to graph that direction. Good. Number 8, very similar, very similar. Pause if you haven't already. You've already read this, hopefully, and we have a budget, of up to, I'm not sure what just happened, up to $750. That's our budget, up to. So look at, here's $750. Can I have more for my budget, or do I have to be under my budget? Right, I have to be under my budget, so less than $750. Ooh, I'm taking this out of order, aren't I? I forgot to define the variable. How much can they spend on one uniform? So this is the cost for one uniform, or a uniform, either one. Okay, we have 15 new uniforms, competition fees of $300, and we have to stay under our budget. Can we be equal to, up to? Yeah, we can be equal to. So we have to pay $300 for competition fees. Plus, we're going to have $15, 15 uniforms at whatever cost we're talking about. That's going to be our inequality. Okay, because it was 15 and they want to know the cost for one uniform and we had 15. So we're going to multiply. Okay, we're going to solve this now. So we're going to subtract 300. Sorry, we have a 300, so we're going to subtract 300 from both sides. So we get 15x is less than or equal to 450. We're going to divide by 15. Now notice we divided by a positive, so our inequality sign is that 30? Let's check. 15 goes in there. A 3 and a 0. Yes, so x is less than or equal to 30. Okay, interpret our solution. Always look back at your question. How much can they spend for one uniform? They can spend, the band, I probably should have said the band can spend $30, oops, or less per uniform. Now, you'll notice that all my sentences are just a little bit different. That's because what hits you? Make sure you answer the question. Okay, let's graph it. X is less than or equal to 30. So we have a 30 someplace on here. That means we have a 31 up here and a 29 down there. Is this an open or a closed circle? That's right, this is a closed circle because it's also equal to. And if I plug in a 29, is 29 less than or equal to? Is 29 less than or equal to 30? Yes, it is. So I'm going to shade in this direction. Good. Identify the error. Whenever they want you to identify the error, you should do the problem yourself first. Okay, so here we go. Cross the line, change the sign. Cross the line, change the sign. Not even going to look at what they're doing. So that gives me 4 plus 2x. Then I'm going to take negative 1/2 times 10. What is 1/2 of 10? That's right, it's 5. So plus a negative 5. And negative 1/2 times negative 4x. Well, what's 1/2 of 4? 2x. You're welcome to use your calculator. I had a negative times a negative, therefore it's a positive. Okay. Now I'm going to combine like terms. Have we found a mistake yet? Nope. 2x, 5. Oh, look, there's our mistake. That's their mistake. They forgot to multiply the 1/2 times the negative 4. So identify the error. The error is they forgot to. So the error, forgot to multiply, forgot to distribute, because it's distributive property, distribute the 1/2 or negative 1/2 to the 4x or negative 4x, either way. Okay, then we're going to correct it. So we're just going to finish our problem here. We're going to combine our like terms. Let's change color so we can see. We're going to combine our like terms. So we get 4x. And then we had a 4 and a negative 5. So or plus negative. You can write this either way. These are both the answer. Okay, good. Number 10, select the 3 expressions that are equivalent to this. And what you want to do with this is you want to do the problem yourself first. So cross a line and change the sign, cross a line and change the sign. Now we're going to distribute, and we get 16n plus negative 36 plus negative 4, because we don't distribute to that. That's an n, if you're wondering. That doesn't get distributed to. Okay, do we have that answer? Oh, look, right here. I changed it to plus a negative, but isn't that the same as subtraction? Yes, it is. So there's one of our answers. Okay, now if I keep on simplifying this, I'm going to combine like terms. So I'm going to take 16 and negative 4. That gives me a 12n minus 36. Do I see that one? Yes, I do, right there. Now the other one I think is kind of funky weird, because what they did is they changed all the signs on this one way up here. Okay, I don't know why my screen's doing that. So 4, and they took and they put negatives. They rearranged what these would look like. Why is that not doing that? Okay, so look back up the original problem, and what they did is they kept the 4 the same. They moved where the 9 was. Then for some silly reason they did this, because a positive 4 is minus a negative. Okay, so B is the answer. Weird, but it is the answer. Okay, number 11. Okay, so let's do the same thing. Cross the line, change the sign. Cross the line, change the sign. Oh, look right there. When you cross the line, change the sign. Look at right here. Right there. Okay, right there. There's no number, but we have a sign out there. Remember, if there's no number, we can put a 1 in there. So that's going to be a 1 right there. And we're going to eventually distribute that to both of them. So we have to distribute here, and that is a negative 2. We're going to distribute here. And if you want, remember, you can use that box. It's a great way to do it. If you're more comfortable with a box and your brain sees that, do that. So we could do this in the box right here. And this one we could do in the box if we wanted to. So do whatever your brain sees. That's the most important part. And then we have a negative 10. Oh, hey, I forgot to cross the line and change the sign. So do it whatever way is better for you. But this next line is going to turn out to be negative 6n plus 12 plus negative 7n plus 10. So no matter which way you did it, that's going to be your next line. Do we see that? Negative 6 plus 12 minus 7n. Here we go. There's one of our answers. Let's keep on simplifying. So now we're going to go with like terms. I have a negative 6n, negative 7n. That gives me a negative 13n. Then I'm going to take 12 plus 10, and I get 22. Do I have that answer anyplace? Negative 13n. Yes, I do. Okay, and now the weird one that they do is they just start rearranging things all over the place. Well, not too bad, I guess. Let's see, I have a negative 6n, and nope, I don't have a negative 12. Nope. I bet it's this funky one. Let's see, negative 6. Yes, look at this. It's this one. You know why? Because I knew the negative 6n had to be there. And then I knew it had to be a positive. Well, if I take minus and negative, that is a positive. So that's the other answer. Kind of weird. Select the two expressions that can be subtracted from 9x. So here's what I do on this. I have to end up with a 3x. So what do I do to 9x? I'm going to take 9x minus what to get 3x? Well, I know I could take it minus 6x. Okay? And if I'm subtracting this whole thing, that means that I have to come out with a positive 5. So I have to subtract a 5 so that I'm going to subtract a negative. So where's that answer? 6 minus 5. There's one of them. Okay, and now just rearrange what I did here. I have 6 minus 5. Isn't that negative 5 plus 6x? Yep. There's my other one. Moving on. Okay, now we get to apply the distributive property. To do the distributive property, if you want to draw a box, it's a great way to do it because your brain might make more sense. So remember, the 2 goes on the outside, 5x goes up here, and the 2 goes up here. And then you're going to multiply 2 times 5x and get a 10x. You're going to multiply 2 times 2 and get a 4. So your answer is 10x plus 4. Now, of course, you can also just distribute here and do it that way also. So do whichever way you works best. So this one, I'm going to start off by actually distributing. Oh, no, I'm going to start off by cross the line, change the sign. Then I'm going to distribute. So I have negative 18x. And negative 6 times a negative 2 would give me a positive 12 because I have an even number of negatives. Okay, now number 15 looks tricky because you have a fraction. No, it's not. But I do have to come over to the side sometimes or take my calculator. 1/3 times 18. I'm going to show you how to do it mathematically. Okay, as if I didn't have a calculator that do it for me. So what happens here is that I divide by a 3 and I get 6. Whoops, that's a 6. So this gives me a 6. I can change this to plus a negative, or I can just leave it as a minus. Now I'm going to take 1/3 times 6x. Again, I can cancel out, divide out by a 3, divide out by a 3, and I get a 2x. Okay? The box works for all of those. Do whichever way is best for you. Oh, number 16, yay, we get to simplify expressions. You know what that means? Combine like terms. Combine like terms if you have any. And sometimes, before we can combine like terms, we have to do distributive property. So yay, we get to do both on this one. It's a good day. So I'm going to first change my, whoops, what are we doing there? I'm going to go across the line, change the sign. Then I'm going to circle my like terms. So 9x and negative 5x is 4x. I'm going to underline this pair, so 3 plus 4 is 7. Now, if I'm going too fast, just go back, okay? Now, number 17, that one is a little different than, remember I had you change number 15 and number 17. So if you were looking at number 15 going, that's not my problem, I changed it, okay? So now, that one I made a mistake on. That should just be 4x plus 2 minus 6x minus 3. So let's cross the line and change the sign on that. So I'm going to cross the line and change the sign. Cross the line, change the sign. Now there's that situation again where we have that negative out there, so I can stick a 1 right there, and I'm going to distribute that to both of them. Okay, so here we go. I have a 4x. I still have a 2. But here I'm going to distribute negative 1 times 6x is a negative 6x. Negative 1 times negative 3 is a positive 3. Okay, so now let's combine like terms. I have a 4x and a negative 6x. That gives me a negative 2x. I have a 2 and a 3, both constants, so I'm going to add those together, so I get 5. Ta-da! Okay, number 18. Again, if you haven't tried these on your own, pause the video, do it on your own. Now this one I'm going to have to distribute first. And if you like the box method, make the box. Okay, do it whatever way your brain sees. So I'm going to take negative 2 times negative 8 and get a negative 16. Oops, that's supposed to be negative 16. Negative 2 and x is going to give me a 2x. So this x just comes down. That x just is still there. Plus, but now I've distributed 2 times negative 18, which we know is a negative 16. And 2 times x, so I know that's 2x. I have some like terms I get to combine. 2x and x. Remember, there's a 1 right here. So there's a variable without anything. That means that's a 1x. So 1x and 2x is 3x. And then that 16 just comes along. You can write it as minus 16 or plus a negative 16. Either way is fine. Good. Number 19, get to do the same thing. We're going to distribute first. So we get 4x and draw the box. If you like the box, draw the box. Okay? I like the box. I also like not drawing the box. So sometimes I'll do one, sometimes I'll do the other. So 6 times 3 is 18. 6 times x is 6x. You need to go with what your mind sees. Now, like terms, 4x, 6x, 10x, plus 18, because there's nothing to combine with the 18. I cannot combine this any further because they are not like terms. One has an x, one does not. So here we go again. Going to distribute. So I get 6x plus 8 plus 5. That is a 5. This is an 8. What are my like terms, people? Hopefully you circled the 8 and the 5. So the 6x didn't have anything to combine with. It just stays out there. 8 plus 5 is 13. Okay, 21, we're going to factor. So if I'm factoring, I'm going to find out what can be pulled out. What can they both be divided by? So look at 55 and look at 20. What can they both be divided by? Now, if you use the box method, you have a 55x here, and you have a 20 here. And you have to go through and figure out what can I pull out. What are they both divisible by? A 5. A 5. Okay? 55 divided by 5 gives me 11x. 20 divided by 5 gives me 4. Oh, I forgot to cross the line. Well, I'm just going to bring it over then. So I have 11x and I have 4. Okay? Good. Let's keep going. Factor the following expression. So what I'm looking for is what do they both have that they can both be divided by? 4x and 16. They can both be divided by a 4. And that's a really good trick. Always take the smallest one and see if it goes into the biggest one. So I'm going to divide them both by 4. 4x divided by 4, I can cancel out the 4's. Divide them both by 4 and I get 1, not blanks. Okay, I get a 1 when I divide. So I get a 1x or just x. 16 divided by 4 is 4. Factor this one. What are they both divisible by? Again, if you like the box, I'm just going to keep doing it different ways so you can decide what you like best. That is sloppy. Okay, what are they both divisible by? They're both divisible by a 3. Now, they both have variables. Are they the same variables? This is an x and this is a y. Nope. So all you can do is take out a 3. So if I take 3x divided by 3, 18y divided by 3, this cancels, divides out to 1. Divide by 3, and I get a 6. So that means I have an x plus a 6y. Good. Number 24, what do they have in common? What can they both be divided by? Hopefully you said 7. They are both divisible by 7. Now, if you want to cross the line and change a sign, that's fine. What's 14 divided by 7? 2x, exactly. Minus, what's 21 divided by 7? 3. If you haven't already, try some of these on your own. Please pause and try them on your own. Look at 20x and 30. What do they have in common? What can they both be divided by? 10, exactly. I'm going to divide both of these by a 10. So I get 2x minus nice x. 30 divided by 10. What's 30 divided by 10? 3. Exactly. There's my answer. Factoring is not hard. Look at number 26. What pops out at you? Well, they're double numbers, right? So what can they both be divided by? 11. Divide them both by 11. 22 divided by 11 is 2. 55 divided by 11 is 5. And they didn't have any variables the same. Good. So those are all the answers. Hopefully that helped.